Now that the transparent mask project and the special relativity project are done, except for writing the papers, it's time to consider what's next in the STO. This paper will show you about where we are, and many of the projects we've had in the past have threads which could lead to more interesting stuff, and those are all possible projects for what's next. The STO is causative and Machian model. It reduces to general relativity and quantum mechanics, which makes it a theory of everything, and explains many problematic observations that both general relativity and quantum mechanics have. It has made predictions, which have later been found to be true. The STO rejects, by experiment, Maxwell's equations, wave models of light, and the idea of the Lagrangian and the Hamiltonian mechanics, which do not have dissipative characteristics. One thing we can look at is the constants of the universe. As a result of negative feedback loops, the problem here is identifying what the feedback loop is. This was done for the cosmic microwave background temperature, which is a typical temperature feedback loop in that paper. Looking at the gravitational constant is another thing we can look at. The STO uses three types of mass, which comes from Newtonian physics. The weight, which in the STO is a plenum gradient onto the surface area of a HOD. The inertial mass, which is in the plenum, so it supports wave actions. And the gravitational mass, which is what HODs cause in the plenum wave. This works well for photon simulation, which was done. So gravitational constant changes with body structure and perhaps with plenum level. The strong equivalence principle here is rejected, but the weak one is accepted. Entropy and the arrow of time is another thing I've been thinking about for quite a while, and it's still quite a problem. It occupies about a foot-high paper on my desk that I should look at. Universe entropy must include a dissipative or friction term. The standard models are Lagrangian and Hamiltonian, which do not. Therefore, the current universe model of entropy is not accepted. Causality of changing events implies energy input or output. If output, then the arrow of time from source to sink, as you see in the galaxy structure, suggests a constant universe entropy, rather than entropy is always increasing, as this current model suggests. We could also apply the redshift equation to the Pound-Rietvik experiment. Z has already been applied to the Pioneer anomaly, all 10 of the anomalies, whereas the standard model only applies to one of the anomalies, which means it's not that good of a model. This model made predictions which were later confirmed to be true. We could apply the photon simulation to reflection, refraction, and the quantum eraser experiments. This has several problems associated with it. But maybe what we could do is redo with the length of the plenum wave as a function of the number of HODs in the photon, rather than using the model of linear dipole antennas. Now, Bohm has suggested a point particle, and the STO doesn't accept point particles, it accepts some extended space. And we could do this rather than indirectly, as the photon simulation currently suggests, as a body with volume rather than a point. I would note something of interest here, and that is these Walker experiments, which use only one drop to make waves, which then cause diffraction when going through a slit. This is why we might look at the length of the plenum wave concerning with the mass of the photons. It may be easier with this to consider reflection. We could apply the rotation curve equation to spiral galaxy orientations. Recently, some papers over the last 5 years or so have noted correlation of spiral galaxy disk orientation in space being somewhat related to their neighbor's position. Now, the asymmetry of the rotation curve was considered, and it considered these neighbor galaxies. And so this spiral galaxy rotation orientation may be considered a prediction of the standard scalar model. This is the issue that we have. Currently, where here you have rotation velocity squared compared to all these galaxies and versus B-band luminosity. Now, you'll note that there seems to be several relations. The slope of each of these lines is twice the previous line. And this area in between the lines is actually a void area. Now, the slope of the lines differ by approximately 2, and statistically, the form is significant by rejection of the null hypothesis that the data points are random. What galaxy characteristic does the B-band luminosity depend? That's the problem. If we could find that, maybe we could have just one nice line in the previous graph. That would also apply for central mass, which was another paper. Another effect of the source at the center of Milky Way we could look for. We've already applied it to RCs, as we said. Planet 9, there's 2 papers on that. Mercury and other planet orbits seem to have some relation to the source in our Milky Way. And of course, the source in our Milky Way was part of the Pioneer anomaly paper. We could expand the idea of structure of particles being like disk magnets to quarks. What that structure is appears to be that it's going to be like electrons being held together by photons is what it looks like. But, I've yet to come up with a structure. I could form a ball of disk magnets, which would be a nucleon, such as a proton and neutron, and do collision experiments using of ball disk magnets didn't work, so perhaps disk magnets would work. We could look for a method to measure the speed of the magnetic force. Now, in the STO, that would be the permanent magnet force, not the electromagnetic force. The STO found that these 2 kinds of magnetic forces of Maxwell's equations are different. Now, one of them, the electromagnetic force, appears to be producing the electromagnetic waves which travel at the speed of light, and that is the speed of Hodds. DeSangro and others looked at the speed of a Coulomb force and found it to be many times the speed of light. And the STO would suspect that the speed of the permanent magnetic force would be a plenum thing and therefore would have a very high speed relative to the speed of light. The trouble is finding a way to measure that. Consciousness is something I think about for a while, but I think before the industry can go forward, it has to define just exactly what consciousness is. And that, of course, is lacking in today's discussions. STO views life and societies as part of our universe. Therefore, the basic postulates of physics should also apply to life and societies. And I looked at that in this paper. But of course, the reverse is also true. That is to say, the characteristics of life and should also apply in physics. That is to say, life expands by means of giving birth. And so there must be a form of birth in physics, which the STO looks at. In the STO, I looked at emergent characteristics, and these are a little different than what most people mean by emergence. But if we apply consciousness to the STO, it could be an emergent characteristic, which means human and animal and plant emergent characteristics, or it could be present in all objects in the universe, such as rocks. Now, this has once been suggested by ancient Greek philosophers when they noted that objects, meaning rocks, tend to find their natural place in the universe. That means they have to know where their natural place is. And also in the view of where Hades is compared to heaven, meaning heaven is up and Hades is down into earth, because the earth was considered at the center of the universe, at the center, but not the center, because all Earth is a gravitron. Oh, well, enough of that. Current approaches tend to view the brain as a digital computer for processing and collating information. Now, the Stowe approach might be very different from that. It could view the brain as an analog mechanism. Therefore, it can have a great many more levels per given unit of time, which means a great many more digital processing rates. We could also, something I've been working on for quite a while, is to consider a third U.S. Constitution. Humanity seems to lack sufficient understanding to form a government with long-term survival. Most types of government organization that we know of have failed in the past, except maybe perhaps for the U.S. one, and yet that seems to be in trouble. The best these organizations have done, such as the Roman Empire, is to transition from one form to another that collapses. That is to say, the nation collapses to a state, such as the Greek city-states, which then collapse to be tribes, etc. And I've written a couple of papers starting to examine this about steering humanity's growth and the growth challenge of the United States. Well, those are the things I'm thinking of for application of the Stowe, but of course, other possibilities are open also.